I'm Jacob. I work at MotherDuck as a developer advocate. MotherDuck is a cloud data warehouse built on top of DuckDB. Hopefully a few of you were able to see Hannes' talk this morning. I'm sure it was excellent. I was preparing this. So I think for those of you who have done a little bit of this exploration, or maybe you're doing it already, like, can you really vibe code SQL? And it's kind of a bad idea, actually. So there's a few reasons why it can kind of be bad and not really work in the way you want it to work. And the first one is, like, you're running on prod. Probably, like, hopefully you're not doing that, but at least for you, like, at least for me as someone who got prod access the first time, like 10 years ago, there was no replica. Hopefully we have those now. The second thing is your workload might not be isolated, right? If you're going to have an AI writing code, you don't necessarily know that it's going to write good, clean SQL, and you might fork bomb your Snowflake instance. Like, be careful. That's an expensive bill. And the last thing is, often when you're vibe coding SQL, your code writing and your execution are happening kind of in separate threads. And if you're doing that, you're not getting instant feedback, in that you're actually having to, like, kind of feedback errors into your kind of LLM workflow. So there's another way that we can solve this problem. And the first one is kind of obvious, but let's use a replica, right? Probably most of you are running analytics on replicas already. What if you can isolate your workload? And what if you could have the LLM run the SQL and fix it too? And so this is where the magic of MotherDuck and DuckDB really comes in to the picture here. And I've put together just like a basic framework of something you can use with Cursor. Here's the link. You can grab the repo also with your phone if you want to follow along. I think, just given our time constraints, I'm just going to kind of go up here and do it. If you want to follow along, great. You don't have to. I think we can learn a lot together without having to spend a bunch of time coding. So with that said, I'm going to hop into Cursor and kind of show you a little bit of things that I've done to prep work to make this easy. And then we can start prompting and see what we get. Okay. Let me escape that. Full screen. Okay. Is that readable for everyone in the back? Yeah, sure. Matson J/cursor_EDA. Okay, so I'm going to talk about a few things that I've put in here that are helpful. And of course, at MotherDuck, we do have some AI researchers. So I collaborated with them really on kind of understanding, like, what does the state of our research today say for writing SQL? Like, how do you make it work? Well, the first thing I did is, because my data is in MotherDuck, I can write a SQL query that looks like this. And it will take the data that is on my cloud and replicate it locally, right? So this is replicating the entire database, FSQ, which is just some Foursquare's data for places. It's their places database, and it's creating it as local DB. I've actually already pulled this because this is a 15 gigabyte database. I don't really want to do that over conference Wi-Fi. I didn't think it would work. So I did that as a pre-step. There's also lots of fun kind of things that I think about here too that I'm not going to talk about, but DuckDB has really nice sampling built in. So if you want to take like a smaller subset of your data set and you don't have, maybe it's not built on, like, modified dates, so you can't just say, give me the last month, just sample it, bring it locally. That also works. Of course, this SQL statement was written by Cursor, not by me. The other thing I did too is I wrote some Python here that takes the schema out of DuckDB and puts it into an XML file. And the reason I'm doing this is because my conversations internally with our AI researchers is really, hey, the best way to get good SQL out of it is to get your schema in XML and pass that in as part of your RAG step. So we're going to do those two things. The last thing that I have here is some cursor rules. How many of you have written cursor rules before? Okay, not very many of you. So what these rules are is they give us, they're basically further context that we can give to the kind of LLM workflow so that it will do things kind of in a prescribed way. So in this project, I'm writing SQL and Python, and so I'm going to give it some very specific rules, and then I can give those as context. So the first thing is I have these SQL rules. So I'm telling it that these apply to all the rules in the project. By the way, Cursor also is great at writing its own rules. So you can say, hey, help me write a rule to do X, Y, and Z. It'll help you do that. And so we tell it about spacing, formatting, format on save, and then this is the critical bit here. So we do have an MCP server at MotherDuck. So if you want to use MCP as part of your workflow, that's definitely possible. Kind of in my run up to this workshop, I've actually found that just interacting with the database works really well. And so what we're doing here is we can actually use this -f flag in the CLI to run a SQL file that we define. So we're telling it, hey, when we write this SQL, let's just run these two, right? And again, this is safe and isolated because DuckDB is on my local machine. If I mess it up, if I get a really bad query, I can just kill the process and start over, right? I'm not going to be in a situation where I'm too worried about the query that's being written. And I think there's a couple other minor things in here that are not showing up at my zoom level. What is going on here? We'll close the terminal. Okay. And then I have some Python rules. The main thing that I want to call out about this Python rule is that I'm kind of taking a very basic set of rules for my environment and letting UV manage almost everything. So because of that, we get to we can kind of just like not think about our Python environment. It just fades into the background. And I think like that's the best way to interact with Python. All right, so I'm in my terminal. We're not going to pop into the cursor quite yet. I'm just going to run my git schema Python. So we're going to do UV run scripts. If I can spell. Ooh. Okay, so what happened? What did I do wrong? Yeah, exactly. Yeah, yeah, I might have to do that. No such file or directory, schema local. Should create it. Okay, well we can use cursor. That's fine. So I'm going to hit Command L, and I'm just going to say I got an error in the terminal. Not sure why. And then I can actually copy this, and it's going to just put it in context in cursor with the @ I think. Yeah. So you see that it added, so here's some context that is going to this question. And so I actually have it on auto right now, which we'll leave on, but I found that Gemini Pro 2.5 kind of is the best model right now for this, for my kind of SQL experience. So we'll run this, and hopefully we solve our problem here quickly. Yeah, this is the fun part of these demos is we get to wait a little bit on the conference Wi-Fi. Let's go. Let's go.
Do you need the local database?
I have the local database. It's here. Do you need it for this? You can use a MotherDuck database. You can use a Parquet file. You can you don't have to have a local database. I kind of recommend that flow. Let me see what's happening here. All right, we're going to stop. We're going to choose a different agent and see if we can get this to go. I guess on Gemini. Okay, interesting. Oh, I don't have a schema folder. That was the problem. That's very easy. All right, so I'm going to accept this. I must have deleted it when I cleaned up my branch. So I can do this. I just accepted the change. And now we'll go back in here. Okay. Go back into our terminal here, and let's get our schema. No, not that. Okay. So now we just have, a beautiful XML file generated by Cursor. Amazing. Okay, so now what we can do is actually start getting into the real kind of meat of this workflow. And so because I have a places data set, I kind of want to constrain it. Let's do something like, I don't know, I'm looking to build a restaurant, maybe in Oakland. Let's look at where other restaurants are. Let's look at density of the area, and let's figure out if we can use SQL to kind of guide us towards where I want to build this restaurant. So let's do that first. So I'm going to give it different context. Oops, get out of there. We're going to take this one out. We're going to add more context with the @ sign here. So we're going to say SQL. We're going to give it our SQL rule. We're going to give it our local DB schema and say, give me a SQL query. Make this slightly wider. How's the text size on this, by the way? Is that okay? A little small? Okay, all right. We're going slightly bigger. Okay. So we're going to say, give me a SQL query for restaurants in Oakland, California. Okay, so we're going to give it two things. That we give it the database schema and the data set, run the query, and see what comes back. So you can see it's thinking, it's looking at the what the categories are, kind of it's reading the schema, right? And now it gives us a query that looks like this, right? Let's see, did it put the query in anywhere? Not yet. Okay. So it's going to generate the query here, which is not exactly what I want it to do. I kind of think about some of the stuff when you're using an LLM. It's kind of like you're handling like a bloodhound. Like it's about the human and the dog, but it's not just about the dog, right? You need to kind of guide it. So we got an error. It recognized what it should do here, actually, which it put a query in here, and then it ran it the way that I want it to run it, right? So we're going to run it. And so we got back immediately 3,000 rows of restaurants in Oakland, where the locality is Oakland and the region is California. And the category label is like restaurant. So it's trying to tell us something else here, too. What is it trying to tell us? Okay. I'm going to make this even bigger. Can I? Oh. Okay, so it is deleting the SQL, the SQL file. I'm going to stop it because it's kind of being a little silly here. All right, we'll accept the delete. That's fine. But we're going to stop it and say, let's create a queries directory and write the queries there. I did. That's pair programming. All right, so we're going to tell it just to do that, so that way we kind of like keep the history. I really actually kind of like this trick when I'm writing SQL with an LLM, because then I kind of just have all my queries there. I'm not worried about like a query history abstraction. It's just kind of all there. I can say, hey, like try to optimize this query. I actually do this like kind of fairly frequently as a way to learn how to use my database. Is like, hey, I have a query. How do I make this more optimal? I can run a bunch of different tests. You know, then I have a bunch of SQL queries that are running kind of different queries. You can also look at the query plan, but that's not very fun. So, all right, so it created some files for us. We'll just accept this, and that's really cool. Now, the problem is a SQL query is just a table. It's really hard to understand when we have a table, like what it should look like. And so here's where we can use Python. And I'm going to see if we can. I can't remember what library. I like my Python skills are mostly based on using LLM, so I don't know very many libraries, but one of them that I know is Folium, and I'm going to use that one. I'm going to say, let's use Folium to chart this data set. To chart, let's see. I'm going to tag it just so it doesn't like, why is it not finding it? I see it right there. Okay, can we drag you in there? Okay, cool. Well, there we go. In HTML and then serve it. then serve it with Python. So I kind of like to, at this point, what we're doing here is kind of building little mini data apps, like just ad hoc, throwaway with an LLM. It's so low lift that we can kind of just ask it to do these things and have it do it for us. So it's running the query. It's recognizing that it needs to get latitude and longitude to use the library, right? So it's actually adding this to a requirements txt, which I don't want to do. So I'm actually going to stop it. Stop. We are using UV, so use PyProject instead of requirements. So this is like where, observing it and helping it and kind of sending it the right way really, really helps. Okay, it's adding pandas, which is fine. I guess we'll use pandas too. So we'll accept these. And now we are starting up a little server. Great. Okay, looks like it even put it in a script that we can run, which is really nice. Let's see if it works. So I guess I need a slash. Okay, so it creates the map and it serves it, and we can open it in the browser. And let's see. Wow. Some of these are in Oakland. Some. All right. I mean, that's pretty good. So, yeah, like that's pretty good. So I like these points, but like it's a little bit hard to see all these points on a map. I want to see if it can actually turn this into a heat map. So we're going to do that, and then we'll go back to SQL. So can we render this? I'm going to kill this process here. Can we render this as a heat map instead of points? And the answer is usually yes, but we'll see if that's true. Come on. Okay. Doesn't like my. No, I think that's actually might be an issue with the Wi-Fi. I can't tell. We'll just go back to auto and see if it'll render for us. Okay, yeah, there we go, perfect. So it's updating our Python now real quickly. Cool, so we've imported the heat map function and we will run it. Sure. And now we get something that's a little more consumable, right? Now, this still isn't that helpful because it doesn't really tell me what kind of restaurants we need to make where. And so what I want to kind of do here is we're going to go back to the SQL and see if it can do some analysis for us to kind of like steer us towards what type of restaurants maybe there's not enough of or are underrepresented kind of in this area. So let's go back into SQL. All right, so let's go back into SQL. On which restaurant types. Oh, see if I can spell it right. The nice thing about tokens is your spelling can be very imprecise. Need to be, let's see, which restaurants are most represented? I'm adding a little hint here because when I did this analysis the first few times, I didn't recognize that there was a is closed flag in the data set, and we were looking at a bunch of restaurants that no longer existed. So we're going to tell it to make sure we only look at restaurants that are still open.
Is this a new query, or is this based on the results from the open set?
So it should take the first query as context. Whether or not it will rewrite it or create a new one, I can probably ask. Generally, I kind of just send the query, send through my prompt and see what it says. But I can ask for a new query. Let's do that. Let's make sure it's a new query. And now we get to see like how good Cursor's logic is at like choosing the right models to like build this stuff for us, right? Since I'm not using Gemini, I'm just kind of relying on what they have here. Okay. Cool. So what's pretty funny here is we have a problem. And I don't know if Cursor actually understands that we have a problem. I don't think it does. And the problem is that this SQL query returns this truncated data set, and it uses cat to send that into the into the space that Cursor can read. And that means we're missing about 50 rows. So it's a fine analysis, but we're going to have it write it out to CSV and then check again. I'll say run the same analysis on it. Okay, so perfect. Ooh, okay, I didn't like that. Great. Let's see, did we get a file? Oh, look at that. Very cool. Can't really see it though. 20% restaurant. Wow, that's very helpful. Yeah, obviously, we're not using this to clean the data set a little bit, although we can, do some types of scoring here. But it looks like we have a pretty good set here. This data looks like we can use it, so that's great. Okay. It's just doing the same thing I was doing, right? Head and 5. Smart. Great. So now it's creating a new query here and running it. And again, we can kind of see what's happening over here. Analyze restaurant categories. Let's see what it tells us. Top cuisine categories. Interesting patterns. Some categories like BBQ and seafood are very homogeneous. Okay. All right. Let's see if it can tell us. Now we can do some like complex spatial queries. So let's load the spatial extension for DuckDB. And let's see if we can identify the 3 locations on a map. How many, let's say 1 acre in size, where we have high density and no, I don't know, let's pick a category. What category?
African.
Okay, sure. And no African cuisine within 1 mile. Score based on number of other restaurants nearby. So we want to open where other restaurants are already located, but where there's none of the restaurant type that we have. And again, we're relying on the Foursquare data here. So Let's see if we can get something fun. What's really cool is I don't really know a lot about spatial, but like I can kind of fake it a little bit by prompting well. Okay, so what's fun here is that because we're running our SQL queries kind of as we're running our analysis, you'll notice that it returned, nothing returned in our data set. I don't know if you caught that, it was really fast. But so the cursor's like, well, that doesn't make sense. I didn't get any results, so let's try again. Right? And so now we have this loop of like writing SQL, running it, getting no results. Okay, let's figure out what's going on here. And hopefully I don't have to actually look at this data, but I may have to. Okay, yeah, let's see if it can fix its own query error here. Maybe is the answer. I think like one of my favorite things about this is like because DuckDB is so fast in running these queries, we get like really fast feedback, which is especially helpful when we have 0 rows returning. We probably get that feedback fast in any database. We may have to actually peek at this. Let's run a diagnostic query. Sure. So it's like it's doing these things, like these are things that I would do as an analyst, right? Like, okay, I'm not seeing any rows. This query seems to make sense. Like, why are we, do we actually have African restaurants in our data set? Okay, yes, we do. Like, do we have other restaurants? Yes, we do. Okay, how do we find these areas of opportunity here given our constraints? We may not be able to find anything here. Okay, this is interesting. I really don't want to look at this query. That's like what I don't want. This is like, it's like reading the docs. Like, I don't want to read the docs. Like, just do the thing for me, please. Okay. So one thing we can maybe do here that I'm thinking about as we work on this is what I can do is actually take that heat map that we built earlier and then map the African restaurants as points. And then I can actually, maybe use my intuition a little bit to kind of determine, okay, it looks like this is a spot on the map where this is somewhere we might want to consider building a restaurant. How do we think about this a little bit more? Especially if our query doesn't work, but it did. All right, hopefully it looks good. Okay, so we're giving a little bit of connection issues here with the Wi-Fi, but that's okay. All right, so let's add these 3 locations as a box for each location as a layer to our map. So now we have our heat map layer, and now we can put on another layer that says, what do these look like? And I think we should be good. One of my favorite prompts to use on Python in particular when I'm charting is like, can you make this look better? And it actually works pretty well. Okay, all right, so I'm going to cancel this because it lost context, right? It's now going into a hell that we've all probably been in, which is what is happening to my Python environment. I'm just going to say cancel and stop. Remember, we use UV. All right. Okay, so I'm already running it, so let me just cancel this real quick, and then cancel. Okay, well that's actually fairly clever. We'll allow it to run it on another port since I had the other one still running. All right, so somewhere in here, where did it go? Okay, I guess I'll have to copy paste this. Wait, no, here we go. That's nice. Okay, did it draw boxes for us? Okay. Yeah. Okay, so I don't see the boxes, so we'll just tell it. See the layer with the boxes for the new, or for the proposed locations. Make it more obvious. So it's possible it didn't work right. I'm not sure because we're vibe coding, so we want to avoid looking at the code here. We'll try one prompt here, and then we can take it from there. This is also like, for these kind of type of like, precise updates, the model really matters in these cases I found. Gemini tends to be very, very good at like taking precise instructions and only listening to it, and Claude sometimes can be a little bit wild. And so, unfortunately, as we kind of progress, and some of you may have experienced this as you progress into like, using these LLMs to drive things, is you end up kind of almost needing like personal evals, which is I think its own set of problems that maybe we will have to take on at some point. But okay, let's see if it figured it out here. Maybe is the answer to this. It also really helps to do this on a bigger screen than a laptop. Also, just kind of so you have, as a human, you can have more context also. Yeah, exactly. Exactly. Okay. Let's see if it's smart enough to fix this problem. Okay, yes, we do. So one thing is, because we're kind of interacting with DuckDB in a very like atomic manner, we're spinning it up to run a query and then turning it off. Every time we are handling extensions like spatial, we do need to kind of include those in our scripts. And it looks like Python is grabbing it here, so it's in context. Frankly, I'm not sure if this approach will work, but we'll find out. Okay, yep. Smart. And last try here. Okay, interesting. Well, this is great. It's fixing its own errors, right? And so like the main thing that I kind of want to get at here is like, because we're running SQL and our Python kind of all in the same loop, it can kind of heal itself, right? And so this lets us kind of observe and intervene instead of like, having to apply the things we're thinking about in other ways. Yeah, go ahead.
Earlier while you were going through this, you noticed that when it was catting, it was truncating out into something else.
Yeah.
I'm guessing you do that because you're very familiar with this data set. You've run this back before.
Yeah, can you repeat the question? Wait, oh, you want me to repeat the question? Okay, sorry, yes. Yeah, okay, so the question was, I noticed that when it was catting, that it truncated the data set. So the default settings in DuckDB are going to basically give you an abbreviated view of the data called a duck box in the CLI. And so that did indeed come from that, but you can also observe it in the terminal, that it's returning kind of a truncated view of just what you can see in the terminal, for sure.
That was just the lead up. I think when it's error in here, it's
Yeah.
very clear that it can't produce something.
Yeah.
We're expecting a graph and it gets an error message.
Yeah. Mm-hmm.
And in that example, you had an expectation that that approach would have a truncation of some sort. But we haven't looked at the SQL at all. How do you know that the data that it's producing is valid? How do we know there's not like
Yeah.
a join condition that's removing half the data set or
Yeah.
number or something like that?
Yeah, really good question. So I think like the way that I like to think about this workflow in particular, like when I am writing SQL and maybe not looking at it closely, charting is really the way that I am kind of closing that gap initially, right? And then as I kind of go along, maybe I'll add tests, right? But I do think that that's a totally valid question, right? Which is like, how do you know the SQL's good? Yeah, we definitely you should look at it. I don't think that it is okay. It looks like our internet's not working right now. So I'm going to pause it here, but I think you all kind of get the gist of this. Oh, it looks like it healed itself. Okay. Anyways, we'll let that keep running. But I do think that's totally valid, and I think like for me, like the data visualization fits right in with the quality of the SQL, which is like I'm going to use that to validate based on what I know about the data set that like the chart looks like how I would expect it, right? That's imperfect, right? And definitely you still need to be familiar with SQL and read the SQL and understand it. I don't think that LLMs are a replacement for like human understanding of the data structures. Yeah.
Could you comment on the schema definition and XML and the impact on the query quality?
Like I know you said your team. Sorry. Yeah. So the schema is defined as XML.
Yeah.
And you mentioned that the AI engineering team mentioned that it does better than specifying the schema in other formats. Could you comment a bit more, whatever you're aware of, as to what other formats can work? Is XML the best way? Why we choose XML?
Yeah. Okay. So first off, it looks like our map rendered, but then killed the heat map. So we are going to we're gonna kill this part of the demo. But okay. So the question was why XML for the schema. I'm not an AI researcher. I just get to work with ones, and their feedback very specifically was, hey, like what we're seeing in state of the art is schema as XML. Give the LLM as much context as possible. For me, that was a good enough answer in terms of how to implement this. I will say it has definitely increased the quality and speed of the SQL that I'm getting. So it definitely works. Am I running evals? No. Like, at some point, will I be running a personal eval? If things continue, yes, I think that I will be doing that soon. By the way, I feel free to ask questions at this point. Yeah.
Cool, thanks.
Yep.
At the beginning, we had some SQL generated, and it kind of knew what to put in the where clause. So
Yeah.
I didn't see the steps before, but is it actually making a query to the local DB to get the possible column outputs there before it writes the SQL? Like, does it have that context?
Yeah, that's a good question. Okay, so there's a couple things. So what's in so with the schema, it's basically doing some work to infer like what those columns mean. There's also, I can't remember if I have that in this data set. There's also column definitions that are fairly robust. Let me see if this is in the data set. I can actually check. Okay, by hitting the right button, not that. Let's see. So there's a categories table here that has a fairly robust set of category labels and like definitions in here that that it queries as well. But yes, I mean, kind of the general flow that I've noticed is that when it has questions about the data, it will sample the data because we have access to SQL, right? Because we've already kind of done the step of bringing the data locally. I don't have a lot of fear about the LLM to like writing SQL and basically learning by asking the question of the data. So yeah, it seems to be very effective in those scenarios to like write effective where clauses without too much context. It's a really good question. Yeah, Taylor.
So I'm curious about your personal use of Cursor here. Two questions. One is, are you almost at the point in this demo where you feel like that chat is losing coherence? Like, how often are you starting a new chat and like bringing things back into it? And then kind of a second question is, have you experimented with just being like more direct with the prompting, and is there any sort of effect on that? Because a lot of what you're doing is like, let's see, can we try?
Yeah.
Or do you just like do this?
Yeah. So I think okay, it sounds like we're done. So we'll answer this question, then we'll wrap. So the first thing is like, how often is it losing coherence? I found that mostly in Cursor. I've used Windsurf as well. That it helps to re-emphasize context when it starts kind of losing, like going off the rails. Like there was no reason for it to like look for the Python environment. We already gave it the rule that said, hey, we're using UV, but it still, lost coherence there. Taylor, what was the second question?
Just the directness.
Oh, directness. So when I'm kind of being, especially when I'm working on Greenfield, I pretty much just like am pretty suggestive. When I'm working on something that's already exists, I will be very precise. And I'll use something like repo mix to give context, which lets you turn lets you turn a repo into XML, and you can use that as a rag step. Also, very, very helpful. So I'll use something like repo mix, and then give it like a much more specific prompt. There's a few really good articles on like writing good prompts. That one of them, which is that I use regularly, is kind of saying, hey, I want to build a spec for a developer. Ask me what questions you need to know, and then just stepping through it. I think here I'll just share the link real quickly for the purpose here, which is this one. So like this is the nature of kind of like an idea honing prompt that I find very, very effective in the scenario of, brownfield specifically, where it's already something that already exists. But for greenfield, I like to kind of be pretty loose with it. Okay, thanks everybody.
Thank you very much.